We are covering soil compaction for the FE civil exam, focusing specifically on the Proctor test, optimum moisture content, and maximum dry unit weight. This is a fundamental geotechnical concept you are almost guaranteed to see on exam day. The entire goal of compaction is to increase the density of the soil, which improves its engineering properties like strength and stability. To measure this in the lab, we use the Proctor test. You must know the difference between the two types. The Standard Proctor test, or ASTM D698, uses a 5.5-pound hammer dropped from 12 inches, compacting the soil in 3 layers with 25 blows per layer. The modified Proctor test, ASTM D1557, uses a much higher compactive effort to simulate heavier modern equipment. It uses a 10-pound hammer dropped from 18 inches, compacting the soil in 5 layers, also with 25 blows per layer. The results of a series of Proctor tests at different water contents are plotted on a compaction curve. This curve has a distinct parabolic shape, with dry unit weight on the y-axis and water content on the x-axis. The peak of this curve is the most important point. It defines the maximum dry unit weight, or gamma D max, and the corresponding water content is the optimum moisture content, or OMC. At moisture contents below optimum, the soil is too dry and particle friction prevents effective compaction. As you add water, it acts as a lubricant, allowing particles to pack more tightly and increasing the dry unit weight. However, if you add too much water past the optimum, the water begins to replace the heavier soil particles in the fixed volume of the Proctor mold, which causes the dry unit weight to decrease. On the FE exam, the classic question will give you the total, or moist, unit weight and the water content of a soil sample and ask for the dry unit weight. You will always need to convert to dry unit weight to use the compaction curve. This critical formula is found in the Geotechnical Engineering section of the NCEES FE Reference Handbook. The formula is dry unit weight equals the total unit weight divided by the quantity of 1 plus the moisture content, where the moisture content is in decimal form. For example, if a soil has a moist unit weight of 125 pounds per cubic foot and a moisture content of 15%, the dry unit weight is 125 divided by 1.15, which equals approximately 108.7 pounds per cubic foot. A common exam trap is to provide data from both standard and modified Proctor tests and then ask a question about relative compaction using the wrong test as a reference. Pay close attention to the details. For example, a project specification might require compaction to 95% of the Standard Proctor maximum dry unit weight. If the lab determined the standard maximum is 120 pounds per cubic foot, your required field density is 0.95 times 120, which is 114 pounds per cubic foot. A field test, perhaps using a sand cone or nuclear density gauge, might measure an in-place dry density of 116 pounds per cubic foot. In this case, the compaction is acceptable because 1116 is greater than 114. The trick is when the problem also gives you the modified Proctor maximum of, say, 130 pounds per cubic foot, which is irrelevant to the requirement. Here's a mnemonic to remember the difference between the tests. The modified test is MORE energetic. It uses a more massive hammer, a more extreme drop height, and compacts the soil into more layers. This higher energy results in a higher maximum dry unit weight and a lower optimum moisture content compared to the standard test for the same soil. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.